Here we go again with the Van Allen belts and the moon landing. The smaller inner belt is from 620 to 3,700 miles above the Earth, minimum and maximum. That's not its actual thickness. It's a toroid, and it doesn't cover the entire sky from North to South Pole. Because it does not. There are no images that show that unless you're looking for some truthy website. It generally kind of stops or gets weaker and weaker as you go further and further north. It doesn't get stronger as you go further north. Electric Universe people do not comment. No, it's not how it works. The more variable outer belt, which can change size, shape, direction, and tilt much more, but the inner belt can as well, is from 8,100 to 37,000 miles above the Earth. And it also has a variable thickness. That's the maximum and minimums. And during certain events, these belts can be shoved in towards the Earth or pushed south or north because the Earth is tilted. All told, and I found the pages that were deleted because a bunch of websites get killed. One of the Apollo missions, we're just going to use a generalization. On the Apollo missions, the command module shielding was aluminum and stainless steel. And the total amount of matter, which is what you worry about when you're worrying about neutrons, electrons, and protons hitting something, how much atoms are in the way, was 16 grams per cubic centimeter. A paper clip is about 1 gram of mass. Take a bunch of paper clips and cram them into the space of 1 cubic centimeter. Yeah. And that doesn't take into account the rest of the random equipment that was bolted onto this. This is the shielding that was specifically, we're just talking just the shielding. The flight trajectories were made to try to avoid the inner belts completely and only pass through the outer belt at the thinnest possible part. Do you see Moon Landing Denialists show you how this orbit worked in an animation or a drawing? Do they say that it's not possible and just not talk about it? Do they overlay the Van Allen belts as they were that week for this? How long did anybody spend in the Van Allen belts? The entire transit, once they started going in such a way that they would go near any of the Van Allen belts, it was only the outer one, which is again 8,000 miles out. The Earth's around. That's a pretty good distance. They were in it for a little over an hour, like 90 minutes max, depending on which mission you're looking at. And it was 32 millirem, or 0.016 rads total exposure, according to different ways of measuring it. And also according to the radiation dosimeters they carried with them, because that would be a good thing to check. Also, prior to this, the people who were going to send them up there fired equipment through to find a pathway with the least radiation. Wait for an opportunistic day when either the layers are thinner or there's a really thin area up, let's say above the 45th parallel, maybe cause it to orbit the Earth and shift the orbit to where you're throwing them up here higher and higher on an elliptical orbit so that they punch through. I mean, you can look up exactly how the orbit was done, or just pontificate about how it's an impenetrable barrier because it's part of God's firmament. Because when you actually dig into these websites, they really do appeal to people who truly believe the Earth is flat, and that's it. I'm not being mean here, that's what you see come up. They're not joking. That's like watching a conservative, quote-unquote, joking about Hitler and hearing liberals, quote-unquote, joking about how, some socialist was right. I don't take it as a joke. If you don't want to be associated with such ideas, don't bring them up. If you don't want to be associated with flat earth myth-making, don't bring it up when talking about spaceflight. You're immediately disqualified because you won't do the physics right, because you don't believe the math works. All without any proof. We can't have any proof. You can't. Let's go get out some big wooden calipers and T-squares to measure the Earth, because that's totally not going to have an accumulated error of 1 part per thousand every 5 miles, which is what you have to not have. And let's eschew the usage of lasers or radio communications for lineup because, well, light bends. Let's go back to this again. They were out there for less than 90 minutes and they collected 32 millirem, thousandths of a rem, or 0.016 rads total dosage going out or coming back in, or maybe combined. Their exposure would be 13 rads per hour max if the astronauts were on the outside of the spacecraft with no shielding for the entire transit through the Van Allen belts while not avoiding them, just going through them on purpose to see what it would be. But it was actually under 1.14 rads over a 6-day period of time accumulative. But on day 14, one of the Apollo ones showed 1.44 rads or something like that. A peak for a little bit of time. The rest of the time it was much, much smaller. That's the exposure to the whole thing. But again, you could literally be on the outside of the damn thing. What's the max rating you can be exposed to? A full human body dose of 5 sieverts is deadly. OSHA lethal dose is 300 rads in 1 hour. How long would you last if you were a typical satellite on an elliptical orbit? We'll get into that. Older high voltage electronic systems and mechanical and other systems were tougher. That's all we could work with, but they didn't have to work fast. They just had to work very precisely and reliably. They had humans mostly doing the controlling after a certain point. Mistakes were made, but you could compensate. Artificial intelligence is not very good at this. We also didn't have it at the time. Low voltage based miniaturized, digitized electronics, logic circuits, and computers have made satellites very much more vulnerable to radiation and electromagnetic energy, because one layer is basically electrons, the other one is essentially protons, which means the electrons have been stripped off of hydrogen atoms, and they're all on the inner belt. And there's also cosmic radiation, gamma rays, that sort of crap coming in between, because these belts also stop certain kinds of radiation. You're in more danger from the radiation outside, not the Van Allen belts. But again, if you shield it, gamma rays can be stopped. They're harder to stop, but they can be. You're going to have to read up on that separately, because we're only talking about Van Allen belts. A satellite with a 3 millimeter aluminum shield, not anywhere near as thick as the ones that were used, on an elliptical orbit of 200 miles to 20,000 miles, really elliptical orbit. So it goes through all the Van Allen belts and crap as much as possible. We're going into them at least. You're fairly far into the outer belt, which is actually spread out more. Less radiation actual total? No. But it's spread out more, so you're exposed to less in any 1 minute. Passing the radiation belts both, this would cause over a 1 year period of time 25 sieverts or 2,500 rem, depending on what you're measuring. Worst case scenario. Almost all of that would actually be just caused by the inner belt, and that would be if you went through it on purpose, just like our above example. Since the full human body dose is 5 sieverts to be deadly, and 300 rads for an hour maximum, you'd last 2 months riding a highly elliptical satellite without dying from radiation. You'd easily survive a few hours, or just 1.5 hours. And that's by not avoiding the blasted belts. But you'd have a 3 millimeter shield. On the other end of it, you had a 16 gram per cubic centimeter shielding of stainless steel and aluminum, differential metal types, also other stuff in between that added to that. Other types of matter, having the effect of stopping a lot of it. They sat down at a table and blasted these things to see if it would stop radiation. Wouldn't you? Oh, no, I would go up without shielding. There's this famous meme that was in a movie where a British person said, I'd like to be the first person in orbit. Well, we haven't figured out how to get you down. Yes, sir. I'm very British acting, and I don't care if I die. There's another one about Gurkha being asked, would you do a skydive to get to the location where you can kill people? And everybody stepped forward except one person, and they asked the guy, why didn't you step forward? And he said, I'd like a parachute. We have these memes about people being suicidally nationalistic or idealistic. These were test pilots who are taught not to kill the equipment, and they were told you have to survive, not because we care about you, but because we need the report. And it makes us look bad. I don't think they would say, oh, don't put shielding on it, that's too heavy. No, how much shielding do you need? Well, let's set up a satellite or a rocket to see what the radiation's like. They did these radiation tests before. That's how they got named Van Allen belts. And you know what happened? They found out what the radiation level was, duplicated it here on the Earth as best they could, and overdid the shielding by at least 2 to 1. Look up what your daily dosage is now. Then look up what it is when you're in an airplane. Now tell me how the plane's got a metal skin on it too. The United States Atomic Energy Commission standard for people who work with radioactivity on a regular basis is 5 rems or 50 millisieverts per year. The total radiation received by the astronauts varied from 0.16 to 1.14 rads total for the whole damn trip. Igor Kostin took 20 photos of Chernobyl 14 hours after the explosion from a helicopter, 200 meters above the stack, and the radiation level was at 1500 rems. He didn't die from that. He died in a car accident a long while later. Didn't show any radiation problems. It's how long you're exposed and whether you're shielded and how strong it is. Now, I'm going to repeat this. They avoided the radiation belts because why wouldn't they? That's not impossible. When you look at every diagram, it shows a donut. Let's say my nose is the Earth. The radiation belt would be about as wide as my pinky here, and out here about as wide as my thumb. That's it. They're literally donut-shaped areas. You can just go around them. You knew that, right? Before you looked at this video. No. It's impossible for us to choose the pathway we do in life or something. Anyway, you must love the taste of that government check. Read below it. I'm substituting words here. NASA claimed they were running low on tape, so they recorded over the recordings. No, they didn't claim they recorded over it because they were running low on tape. Someone didn't recognize the importance of the tape because it wasn't labeled correctly. If you don't label that floppy, important data, don't erase it, barnyard porn, it's going to get erased because you didn't look. When you record video recording, you leave a liter distance. Unless you label it with a screen, you don't know what's on it. They put it in the machine, ran it forward. Okay, I don't see anything. Let's assume it's blank or not, but nobody bothered putting a note on it. If you're not aware of this, the problem is you put notes on the exterior casing instead of the reel itself, or a piece of tape, tag. And tapes, which kind? You're the expert, right? Next. They also call it lost technology. It's too expensive to replicate. You really believe that? Billions of dollars per year and advanced technology ever since then, and they can't replicate something they did before vehicles had electronic ignition. Do you know how to make a pocket watch? If you didn't have a manual for it, did you know how? Do you know how much technology is lost? Do you know how to make a zip drive work? I do. Not to mention thousands of miles of radiation belts that you ignored the entire pathway for to make that comment. Thanks for watching. Have a good day. Good luck with that. And please post a way and downvote the hell out of this.